All right, we're going to cover section 1.1, solving one-step equations. The objective for today is at the end of this lesson or at the end of the assignment today, you can solve a one-step equation with a one unknown variable, and you can kind of check off that box. So a quick review of some vocab. An expression can be numbers, variables, constants, or a combination. This is no different than a written expression. A verbal expression, use obviously words when you express yourself. An algebraic expression in algebra is anything that uses math language, such as numbers, variables, constants, or combinations. So for instance, the number 2, that is an expression. Comma 2x plus 5, that is an expression. So it's got numbers, it's got variables, combinations, operation symbols like a plus or minus sign, anything that you use to express that math language, that is an expression, specifically an algebraic expression. An equation is a mathematical sentence that uses an equal sign to show two expressions are equivalent. So an example of this, again, 2x plus 3, or let's go back to the expression we used above. 2x plus 5 is an expression. And then so is the number 2. That's a different expression. Those are two expressions right now, but if we put an equal sign between the two, that's what makes it an equation. And then finally, a solution is a numerical value for the variable that makes the equation true. So for instance, in that equation, 2x plus 5 equals 2. If we replace that x with negative 1.5, that would make this equation true, because 2 times negative 1.5 is negative 3, and negative 3 plus 5 equals 2. So negative 1.5 is the solution. And then finally, the most important thing probably from this section is how do we determine what the solution of the equation is? You must use inverse operations. Sometimes in class your teacher may say opposite operations. Kind of means the same thing, but more specifically, inverse operations are operations that undo each other. So for instance, if you gave $2 to your best friend one day for lunch, and the next day you take away those $2, those are inverse operations. One day you're adding $2 to how much money he has, the next day you're taking $2 away. So those operations undo each other. And the two most important we'll talk about in this first section, addition, subtraction, those are operations that undo each other. And then multiplication, division. You'll need to recognize that those are also two operations that undo each other. So that's how we solve one-step equations. We use an inverse operation to get the variable by itself. You can forget everything else in this section if you remember and understand how to do step number 1. Use inverse operations to get the variable by itself. I would encourage you to read through this. This just kind of explains more of what I've been talking about how to use inverse operations. But let's look at some examples. So example 1, x plus 10 equals 15. And I know you can probably solve this without using inverse operations, but you want to get in the habit of doing this the right way, so when harder problems approach you, you'll have a method to solve them. So we've got an equal sign. The first thing we want to do is, that equal sign is really the middle part of the equation, even though it's not exactly right in the middle. We're going to treat it that way. So x plus 10 equals 15. To solve for x, we need to do the inverse or opposite operation that's being done to it right now. And right now, a 10 is being added to that x. So to undo that operation, we're going to subtract 10. But we can't just subtract 10 on the left side of that vertical line. We have to do it on the right side as well. So whatever you do to one side of an equation, you have to do to the other. So 10 minus 10, of course, gives us 0. So we're left with x plus 0 equals 15 minus 10 is 5. If you're a mature mathematician, you know that anything plus 0 is just itself. So this ends up just being x equals 5, and that's our solution. You want to get in the habit of checking your solution. So when we take 5 and substitute it back in for x in the original problem, instead of x plus 10 equals 15, we get 5 plus 10 equals 15. And of course, that checks out. Let's do a couple more. The next one is 10 equals b minus 6. So it's a different variable. It's not x this time, it's b. It's the same idea. We'll draw a vertical line right down the middle. And we're subtracting 6 from b. Remember, our goal is to isolate the variable, which in this case is b. So we're subtracting 6 from b. So the inverse operation of a subtract 6 is we're going to add 6. We're only going to add it to the constant. We're not going to add it to the variable because those are unlike terms. So we add 6 to both sides. On the left side, 10 plus 6 gives us 16. On the right side, we get b. Negative 6 plus 6 is 0. And at this point, you can probably stop writing the 0. And we end up getting our answer of 16. Let's double check it. And 10 equals not b minus 6, but we want to take our solution, 16, and substitute it for b. 16 minus 6 is 10. 10 does equal 10, so that solution checks out. The next one, 4k equals 12. A habit that might be helpful for some of you, because students really struggle with this. When the number and a variable are pushed together like that, that means multiplication. So I'm going to put a multiplication dot there between the 4 and the k. A lot of people see that positive 4 and they think, oh, we just need to subtract 4 from both sides. That's not the case. This is 4 times k equals 12. So we have to do the inverse operation of multiply by 4, which, remember, the inverse operation of multiplication is division. So we're going to divide both sides by 4. We're going to use this fraction bar instead of the division symbol to simplify this. 4 divided by 4, what is 4 divided by 4? That's 1. So we get 1 times k equals 12 divided by 4, which is 3. We don't really need to write the 1. So a mature mathematician knows 1 times k is really just k. There's an assumed 1 in front. Equals 3. And let's just double check the math. Instead of 4 times k equals 12, we're doing 4 times 3 equals 12. And 4 times 3 is 12. Our last one, b divided by 3 equals 5. Just a side note, sometimes you may see this written as 1/3 times b equals 5. I'm not going to write it that way, but just know that those mean the same thing. Because remember, there's an assumed 1 in front of that b. So we're dividing b by 3, so we need to do the inverse operation. Instead of dividing by 3, we're going to multiply. Specifically, we're going to multiply this numerator by 3. And whatever we do to one side, we have to do to the other. So on this side, we get 3 times b at the top, divided by 3 at the bottom. On the right side, we get 5 times 3, which is 15. 3 divided by 3 is just 1. So 1 times b equals 15. Mature mathematicians know we don't need the 1 out front, so 15 is our answer. Now let's just double check it. Instead of b divided by 3, we're going to take our answer for b, which is 15, and divide it by 3 to see if it gives us 5, and it does. 15 divided by 3 is 5. Try this last one on your own. 6x equals negative 24. Remember, the goal is to isolate the x in this problem. So try it on your own, see what you do. I'm going to give the answer here in about 5 seconds. 3, 2, 1. So there's my work, and there's my answer. I got an answer of x equals negative 4. And of course, when I take negative 4 and substitute it back in for x, 6 times negative 4, a positive times a negative, gives us a negative. So negative 4 is the solution.